Then today I want to go over the reading that we gave you and talk a little bit more about concrete and answer some questions. I know I actually made the reading and the workbook an assignment now, and they're due next Tuesday. So today's Thursday, they're due next Tuesday. And I am going to share my screen and show you so today I want to sort of work with you on that. Has anybody had a chance to actually, probably not, but has anybody had a chance to read chapter 29 yet or look at it at all? I'm guessing the answer to that is no. Okay, that's not a problem. We'll start looking at it today. So I just want to show you what the course will look like for you. The week of February 22nd, that's where you want to be. And you have two assignments over here on the right. This shows you what's upcoming in this class. And these are due on March 2nd, which is, I think, Tuesday. And one of them is, first you want to read the reading, and the other one is the workbook. And I'm going to open this folder and look in here too. And these are contained in here. Here's the reading right here. Here's the workbook right here. There are some other things in here that you can do if you want to, okay? And they're sort of interesting. And I'm going to click on one just to show it to you. These are code simulations. And I haven't looked at this one. I've looked at for other construction code simulations. Let's take a look at this one. See if we can launch this. Sometimes these don't launch. Yeah, this is one I'm not getting anything here. This happened to me yesterday too. So these don't somehow launch on Chrome. Let me go into Firefox and launch it on Firefox.
All right.
So
Hey, Murray.
Yes.
You want to make me a host?
Oh yeah, I thought you were already. Huh? Oh, I know. I got interrupted because you told me that you were trying to call me, and I was like freaked out. Okay, here we go. You're on.
Okay.
Okay, so code simulations. So here we go. MindTap code simulations. I'm back in Chrome. Let me go back here.
Did you do it yet?
Here we go. Somehow it doesn't work in Chrome, but it works in Firefox. So, all right. Sherelle, are you there? Are you looking at this?
Yes, I am.
Okay.
Did you hit that host? Did you hit that host button yet?
Yeah, I did. I thought I did.
No.
Let me go back and do it again. Make co-host. Did you get it? You have to maybe move your thing. Oh, I'm sorry. I guess. Oh yeah, I have to push another button that's underneath the thing. I apologize. There you go.
No worries. No worries.
Okay.
She's co-host now.
She's co-host now? Okay.
Yeah, I can see.
So this is different things in the code, and they're like, for example, number 1 is pointing out this, and they're asking, is the anchor spacing right? So click on them, click on the ball, and see what foundation anchorage or anchors are about, right? And you can read this whole thing, see what the code says about it. I mean, then there's a lot of code, right? And you can then decide whether this, and actually you can move around too, right, on this. Yeah, there it is right there. And you can decide whether and these are these the anchors? Which are the anchors, Sherelle? I'm not really sure.
The shorter ones.
Up on top or down below?
Down, you see those little short things that have what looks like a washers around it.
Yeah, right here. You
Yeah,
see my,
those
yeah.
are anchor bolts.
Okay. Okay. So we want to see, we want to read the code and see if, how far apart they have to be, the spacing. Bolts shall extend a minimum of 7 inches, but we're talking about the spacing. Well set plates with foundation with a minimum 1/2 inch diameter. Bolts spaced a maximum of 6 feet apart. So, how do we tell? I'm looking at this carefully. I don't know if you guys can see it. How can we tell what 6 feet apart is on this? What to look for? A connection will be required.
It says right there 5 feet. See on the wall, that 5-foot measurement. Look on the wall.
Yeah, let me go back on this and see where I'm going here. Go back to, are we looking?
You just came off of it. It was right there on the wall.
When I clicked here?
See
Oh,
that
there we
5
go.
foot?
Okay. Yeah, okay. So there, oh, I see. This is, I see what you're saying. So that, when I clicked on that, that opened up a new window and it showed me from a different perspective. So it shows exactly. So a connection be required at the top of the foundation. Okay, so this has to be a maximum of 6 feet. So this is 5 feet. So then you would give this a pass, right? It's either pass or fail, and the reason it fails. So, but you know what? What the one thing I'm not sure of, by the way, on this is 15 inches from the corner. I don't know what the code says about that. They can be, oh, look at this. The anchors can be no further than 12 inches from the end of each piece of plate. Is that what we're talking about? Okay, so it looks to me like that doesn't pass, and it doesn't pass because.
But it's it talking about the plate, like the actual wood, or the corner?
I think it's
Because
ooh,
if it's on the bottom plate, then the anchor is not gonna be more than 15 inches, right?
yeah,
Once you
but
put the wood.
it has to be talking about the corner because the wood is only 3.5 inches wide.
Okay.
So they're saying
So
from the corner.
yeah, yeah. So it says no more than 12 inches from the corner, and this is no more than 6 inches on center. Okay, 6 feet on center. Oh, this is sort of cool because this explains all the code. So when you push on, okay, this is great. So when you push on the I for information, it shows you what to look for. It shows you what the measurements and the actuality of it. So a connection will be required at the top of the foundation wall between the masonry foundation wall and future wood framing. Future means that's going to come up. There's no framing there now. Wood sole plates must be anchored, okay, with 1/2 inch anchor. So the sole plate is going to sit on top of this, right, and going to have a hole in it, and this rod is going to go through it, or that bolt, sorry.
So how much is the wood? 3 inches?
Well, it's not about the wood, I don't think.
It's because it's confusing because it says the anchor can also be no further than 12 inches from the end of each piece of plate material.
Yeah, but the plate is down. The end of the plate is. Oh, I see what you're saying.
So, yeah,
Hmm.
yeah, and it's
You're
called
saying
salt plate, right? The wood
you're saying it's a possibility
You know what?
that
Yeah.
that it might
Yeah.
be talking about the plate because it says from the end of each piece of the plate material, which is well, I think it's a possibility with the salt plate. It's talking about the wood once it's put.
yeah,
You know what? You
so
know what, Murray? That's a little bit confusing because
it
I could
is.
see. Yeah, it should be saying it should say from the end of the wall, but it says from the end of the piece. So
And we
technically,
and we don't
at
know the
15 at 15 inches, it's probably within whatever they're talking about. It's probably within the boundaries.
but yeah, well it's potentially aren't you saying I'm sorry, this is a little technicality, but I'm just really
It's a
curious about
basement,
it.
right?
So if they're talking about the wood, basically it will pass because the wood is what 3 inches, right? You said.
Right, 3.5 inches.
So that
Exactly.
will
Well,
be then 12 inches, which is the code.
Exactly.
Once the put is the sole plate is on there, it
mm-hmm.
should pass.
Yeah, I want to just show I want to just talk about for these guys, like explain what you're talking about. You're saying there's going to be there's going to be a sole plate here. Is that right?
Yes. The
Yes.
sole
And
plate.
then there's going to be a sole plate here.
Right.
Right.
And so
So see the measurements also right there where it says 5 foot. It's from the side of the bolt. It's not on the center. So it should be 6 feet on center, which is saying here.
no, but it has to be a minimum of 6
Minimum.
feet.
So 5 feet is okay. Ours
Yeah.
That's
are
why.
4 feet.
So it
Yeah.
should pass, right?
Yes.
Well, this one passes. What we don't know is if this one passes because this says
So-
15 inches.
So
Is
so
it
what
fit-
I'm
Go
I'm
ahead.
sorry, Murray. What I'm saying is I think the confusion lies because that opposing one that you have there, um, it's actually a different plate altogether. So it doesn't count. They're actually talking about from the end of the where you see that 5 foot one, that
Yeah.
horizontal one there. They're saying 12 inches from the end of that board should be
Yes.
another one. So
Yeah,
it
yeah.
actually passes.
Okay.
I would
Yeah.
go past 2. I would say.
Yeah. Yeah,
But-
because the other board doesn't count. The other board is a totally different board.
Right.
Okay, so we're going to be able to see. We're going to be able to see this.
Now,
Yeah.
now, now I'll tell you something funny. So I'm not sure how they reason it out here in the field, but the guys tell me that it needs to be 9 inches, no more than 9 inches from the corner.
So that's
and
12 inches
and then
theoretically.
and then no, it says they say from the corner. They don't say
So that's
from the
only
end of the
could be
board.
like maybe 6 inches.
But
Depends
you have to have a hold down somewhere. So a hold down is on one end and an anchor bolt is on the other, and then the anchor bolts are 4 feet apart. So they just did it that way, I guess, to make sure that they pass whatever questions that they may have.
Okay, so look, you guys are correct because I just did it. I said fail too far from end of plate, and that is correct. Oh no, you said it passed.
Yeah, we said
It
it
fails. Yeah, no, it
Okay.
fails. And so they're going to the corner then.
Yeah,
They're going to the corner. Yeah,
Because it depends on where that sole plate is. I mean, I know this is, I don't want to beat a dead horse, as they say in English, but it depends on if you're okay. If this board, I'm going to draw this board really quickly. If this board goes all the way
right
to here, then that's then 15
then it
inches
fails.
is too far. Then it fails.
Then it fails.
So,
yeah.
So you know what? One thing I'm thinking about that is probably don't read too much into it. If they show you the measurement to be, I go through this all the time with tests because tests have a lot of technical issues inside the test. Do you know what I mean? Like, do they mean this? Do they mean that?
I have a question.
I see, yeah, go ahead.
My question is, it said that it was 15 inches, right?
Yeah.
And I was thinking it said it was too far from the plate and it failed because it couldn't be over 12 inches. That's what I was thinking. And
yeah, no, but these guys were, these guys are agreeing with you, but they're saying something else. If there, this turns out, but if there's a sole plate on this, if you can you see my,
yes.
If there's a sole plate that goes down there and extends all the way to this edge.
Right, and it can't be no more than 12 inches. But this here is saying it's 15 inches. That's the reason I thought it failed, because it was longer than 12 inches.
No, you're right. That is the reason. That
Oh,
is the
okay,
reason.
okay.
Yeah, that is, no, you are absolutely correct.
And
Okay.
and
Their
you know what?
argument was slightly different, that
Right.
Okay.
if there's another sole plate here, then then that would be 3 inches of that sole plate, then it would only be 12 inches from to
Okay.
here. But what I'm saying is, and yes, your thinking is correct. And the answer to the test, what you're saying is correct. So I'm just saying that take this literally. If it says 15 inches, that's probably what they're talking about.
You know what?
Okay.
You know what else too? Murray, go back to the other picture from the top view.
Yeah.
So you see on that right hand side how that the board that, and I'm saying this for Roberto as well. You see how that board is coming in toward us, and so when you start talking about the double top plate and the top plate and how they overlap and lock in,
Yeah.
so that our board would have to go all the way to
Oh,
the end
it
to
overlaps
lock
on
that
the,
other
okay.
side in
You're
and turn
right.
that.
It overlaps, doesn't
Yeah.
it? Okay. Yeah,
Yeah.
you're right.
So
Okay. Okay. So that's a little technicality, but anyway, I love this. This is great. You guys can spend as much time on this as you want to. It's a really great way to learn the code. Some of you who are really into this, like, I don't know, a lot of you, but this will be really useful to you. Sean, you would love to learn the code, I'm sure. This is really interesting stuff. So let's just try one more while we're here. It's so much fun. Okay. Okay, so foundation, masonry foundation walls. Concrete foundation walls shall be selected and constructed in accordance with the provisions of section W. So this is the code. This is the design required. Concrete or masonry foundation walls shall be designed in accordance with the accepted engineering practices. Okay. Walls supporting more than 48 inches of unbalanced backfill, meaning backfill is coming from the outside dirt that's coming in on it. That do not have permanent lateral support. Okay, killing me. I have no idea. Let's just click on this and see. Here we go. What to look for. Verify the installation of 12-inch masonry foundation walls with reinforcing, and IE is the same as, it's like a further explanation. That is rebar, foundation walls with reinforcing, and it meaning rebar, according to the approved plan, in this case, a minimum of number 4 rebar, 1/2 inch thick. So this is number 3 rebar.
It already failed because it says the number 3 rebar right there.
Okay. Now, what I don't know, Sherelle, maybe you know this, or maybe you know, and one of you guys knows this, Roberto, maybe, is 4 bigger than 3, or is
Yeah,
it
it's a little bit thicker.
4 is thicker? Okay. Okay, good. So it needs a minimum of 4-inch, and it has 3-inch rebar, so that's going to fail. It says, note the height of the basement wall is 8 feet. There is an unbalanced backfill of 7 feet for the foundation basement walls. You should know hollow concrete masonry units. These are hollow. Hollow means there's nothing inside of it. It's just empty. Hollow masonry units are available in various widths. This is a little more information. So we're going to say this fails, right? And
I'm not a professional. I can see the stuff wrong with it.
Okay.
Well, just for the number 3 right there, it's
Yeah,
like
exactly,
they
right
gave it
away.
right away.
Okay. But now we have to say it fails because of the rebar type. Okay, fail. Incorrect rebar type. Yes. Okay. Very good. Okay. Excellent. Anyway, this is there for you. Please have fun with this. Try it out. The great thing about it is it explains everything right here. You don't have to know anything. You just go into it and you start learning it, man. It's perfect for people like me who don't know anything about this. This is great. Okay. So again, to go back, that is in the folder the week of February 22nd. There are a bunch of code simulations for framing, more about foundations. This is great, man. This is really great. If you're into it, which I hope some of you are, get into this and start checking it out. Okay. I want to look a little bit at the what we started here with, which is you're going to read chapter 29, which is there's the reading at the top, chapter 29, and I'm going to go back one to see what it looks like when you first log on, and you'll see this on the right side, and so you'll want to click on the reading, do the reading first. And I'm not, last Tuesday, I kind of just previewed it very quickly, but I just want to, I want to help you work off of, I'm going to start with the workbook and find some of the answers in the reading from the workbook, because most of you haven't read it yet, but I just want to sort of give you a tip. I want to sort of, we can work together and find some of the answers in the reading right now, just to give you a little heads up, a little help on it. So
Yeah,
go ahead.
Mr. Cohen, I had
Yes.
a thing. Yeah, I tried doing that, and I tried going back to the workbook and answer the questions. And when I tried to go back to the questions, I had a hard time finding it.
Okay,
I don't.
that's what. So
Because I have a phone, I think that's why.
okay, but that's a really good. What you said is really important,
Like,
because
you would have to like start over, you know.
it's hard. It's exactly what happens. So you can't open two. Here's what I'll just give you the. This is too much information, but the technical of this. We use these books are from a publisher that's called Cengage, and it's National Geographic or something like that. And so we are seeing the book in Schoology, but it actually takes you to their outside site on which you guys are registered and allows you to go into it. The problem is it has to load up out of our site into their site, and it has peculiarities, and one of them is you can't easily go back and forth, and you can't have it on. So hold on a second.
Murray, here is your reminder.
Sure.
Hello.
I changed it from take your vitamins to hello.
Murray, here is your reminder.
Hold on, sorry.
Hello.
Okay, sorry about that.
Papa time.
Exactly.
Sorry. Better way of putting it, but
Oh man, I'll tell you. Okay, so what I did is this. To show you guys, I did this earlier today. I copied and pasted the workbook into a separate file right here, and here's the work. Yeah, because it's too hard to go back and forth. You're exactly right. So what I copied it. I mean, I selected it, I copied it, I pasted it into a Microsoft Word file. So if you would like to do the same thing, it kind of makes it easier to do.
You probably need to be on a computer to do that, though, not your phone.
Oh,
no, I
yeah.
have the Microsoft the whatchamacallit for like typing and stuff like that. I have that. All I have to do is like get it and like download it onto a computer or
Yeah,
through Bluetooth to a printer and do it like that. That's what I print out.
Yeah, you can
I have
print
the
it,
app.
or you can copy and paste it, or
Yeah.
yeah. Sorry about that. Usually, other things you can open two windows at once, and you can kind of be doing it. So
It's just Microsoft app, and it kind of pops up and it has a big old blue M on it.
yeah.
It looks like a notepad on it. What it looks like. I found it out like 2 weeks ago.
Oh, good. Okay. So, and if you guys want to take notes on this, you can probably learn as much as you'll learn from the reading. So we want to write the letter for the best answer on the line next to the number of the sentence. So the style of foundation that is used to reduce building costs is, and I'm going to go back to the reading.
C.
What would you say?
I think it's C.
Yeah, slab on grade.
See.
Yeah, well, yeah, that is the answer, and they do explain it in the reading. And Sherelle explained this to me the other day when we were talking about this. And why is that cheaper?
You have less lumber costs.
Okay.
You don't have to deal with the floor joists and girders and beams and posts and all.
Yeah. So
Make it a log cabin.
yeah, well,
Make it a log cabin.
I'm just going to show you here really quick. Let me show you a raised foundation floor joists. I'm just see if I can find a still picture.
Okay.
Okay, here we go. Perfect. When I was in my basement the other day, I kind of showed you the same idea. You know, this is all not so good anymore. It used to be this images would take you right to the image. Now you have to go to the page. This shows this is not a this is a interior wall. Can't remember what they call this. These are like piers, but on a floor there's a foundation that goes all the way around, right? And then you have to put then you start building the floor. You have to have floor joists, all this big lumber that sits on top of it. Is that correct?
Yes.
Okay. So when you have a slab foundation, I go back here, that's a lot of lumber. It's a lot of building, a lot of time. Slab foundation. You don't have to build all that in between structural stuff, right? This actually has it because it's a raised floor, but you typically don't need it. You just start building right. So here's the slab, right? You have the sole plates. Describe it for us, Sherelle. I'm sorry, I'm not the expert on this.
You basically go from the slab to building walls. So you start with your bottom plate, which is going to be a pressure treated lumber, and then the studs and the top plate, double top plate. So you just start building walls right on top of the slab.
Yeah. So here's the anchor bolts right here. They put the sole plate on it. They just immediately, you don't have to have any of those cross members, the floor joists that go across there. You just start building on it. I don't know, is it in the end, is it more expensive to build a raised foundation, or is it just fat with the cost of concrete and all that stuff, or is it just faster?
It's faster to do a slab, but you just have to decide what you want and the purpose of why and why you want it, because overall, long term wise, I would much rather have a raised foundation, because if you have any plumbing issues, or you want to get up under there and do electrical, you can just crawl up under the house and do what you need to do and fix it and get out. But on the slab, you have to really think about your whole process and how you're gonna go about repairing something if it goes bad on you.
Does it
And
also
you-
depend
and-
on the environment?
Say it
Like,
again,
the
Alex.
raised- Does it also depend on the environment that you're in?
It does.
So like in Northern California, it rains a lot, so you have to do the foundation differently than the southern part of California, kind of thing. You
Yeah,
know?
actually, this is actually in the reading. They talk a lot about about frost and the frost line, like
Right.
how deep the ground freezes.
And
That's what I
water,
was
water
thinking, like-
and water level as well, because if you think about Galveston, Texas, the houses are built on. If you pull up some houses for Galveston, Texas, everything's built on 8 to 12 foot walls.
That's
So
also.
you can literally drive a bus underneath the house, and that's how high up off the ground they are.
I
Yeah,
also found out that partly why a lot of things in Texas are freezing, it's because a lot of the pipes are exposed and above ground. They're not that far deep. Unlike some other states like Alaska, which is like 3 or 4 feet on the ground, so to stay warm. So that's how a lot of the pipes are freezing in Texas right now.
yeah.
That's
It's
what I
like
found.
a sort of unexpected weather.
Yeah.
Huh?
It's not like unexpected. Yeah, it's like not supposed to happen. It's like
Okay.
California freezing like day after tomorrow.
Yeah. Okay, let's go to number 2. So the answer to that one is slab on grade. Number 2, the term CMU is used in construction to stand for, and this is actually in the reading.
It's
Uh,
A.
Yeah, concrete masonry unit. And it sounds to me like you have read this, Willie.
No,
And
I just
You just
got
know.
lucky.
And I'm looking at Sabi there, and she looks like she's making gestures. She might have read it. I'm not sure. So she seems to know what that is. I can't tell. So let's just go into this. I just want to show you. So concrete masonry unit. So let's see CMU. I'm just going to do a search here. I don't remember where it is, but it's actually on here. CMU. Look at how I'm doing it.
Yeah.
Oh my goodness, it's so easy.
You just passed it, Murray.
Did I really?
One more back. See it in that block, in that box right there.
Oh, yeah.
And it's right up above it too.
There you go. I didn't see it. Okay. You're better. So I'm telling you, Sherelle, I say this about you all the time. Tell me if I don't. You have a good eye that I totally don't have. Okay, concrete block foundation is made by stacking together concrete masonry units. That's the technical name for them. We know them as like concrete blocks,
Right.
right? So CMU. So something that to keep in mind in your further work. A type of foundation that is typically installed in one day. That's fast, man. Is CMU precast concrete, postcast concrete, ICF? Anybody know the answer to that?
ICF. Precast.
That's two guesses.
I think it's I know what you're talking about. I think it's later we're going to get to ICF. I think it's B, precast.
It's
but,
precast. Yeah.
yeah.
I lost the screen.
Here it is right here. Precast concrete foundation. And this cast means it's formed and they truck it into the site and they lower it in with a crane. So there it is right there. Precast foundation units. Setup time is typically 1 day.
Oh, there's
That's
the
a,
answer
that
for the
you see that a
next
lot.
question.
You see that a lot in commercial when you go to work and come home and there's 4 walls to a big warehouse building standing up.
Yes. Yeah, they call those tilt and something or other. I can't remember.
Yeah, tilt up.
Yeah, tilt ups. Yeah. A friend of mine used to actually sell those. Okay. Installed in 1 day is a precast concrete. Now, here is the term that you guys were talking about, which is ICF. So the term ICF stands for International Cold Forces, Interconnected Forms,
See,
Isolated Concrete Forms. Okay,
it's
you said
D.
D as in
it's
David.
Insulation
D.
form.
Yeah, exactly. Yeah. So, and we're gonna ICFs, and that is actually in here too. ICFs, insulated concrete forms, which are really interesting to me. I don't know that much about it. Sherelle, I don't know if you're that familiar with it, but
The foam forms a place for you to pour that concrete, I do believe.
yeah, exactly right. So here, I'm just going to show you a little touch of a little. I'll turn this down. So this is a This Old House episode, and this is.
Oh,
I
that
see
all
it.
stuff is awesome. I know that wood, that stuff that they used to wood. It's like they're using different parts of the world now. I seen that.
This is concrete forms right here.
So it's made of
Okay.
foam, right? It's not wood, it's foam.
Yeah.
Foam.
No, it's it's like a foam. It's like recycled plastic. It's like
Oh, I'm sorry, I'm going too fast here. These are, but this is interesting because
You're actually putting them together piece by piece, huh?
That's right. We're going to use a web.
it's like it's supposed
They're
to be
10
safe
inch
for the
web, so
environment.
we have a
and, like
10-inch
cheaper.
space between the two forms when we
Yeah.
assemble them.
Look at that. So it's a piece of plastic. It's pretty rigid. And when you say 10 inch, can you choose different sizes so that you can make this wall thicker or narrower?
We can. We have 4, 6, 8, 10, and 12-inch core thicknesses standard.
Gotcha. Okay. And those are just snapping into place?
They snap into place because we don't want the forms moving or shifting while we're casting them.
I got to tell you, even though I've seen it before, when I hear that a piece of plastic and some foam is going to get filled up with all this concrete and stay together, it's a little implausible. I mean, how is that possible?
Well, they're designed to carry 600 pounds at chest height when we're casting concrete into them.
And that's obviously more than the
Awesome.
concrete weighs going in.
That's correct.
Yeah,
All right. Well, we'll find out in a few minutes, won't we?
they're pretty strong.
All right. So you snap those all together, and then you've got yourself what? An individual, what do you call this? A
This is a form.
form,
what we
okay.
refer to it, yeah.
How are we affixing the form to our concrete footing right here?
Well, the first thing we're going to do is cast a footing that's perfectly plumb and level because we don't want this thing to shift and move. So we'll do that, and then we'll snap lines on it just like a standard footing would do. And then we're going to use an adhesive. And once we've assembled them in place and we've set them to the line, we're going to take the adhesive and then just put a bead right along here.
That's all it takes, huh?
That's all it takes.
So that's not actually stopping us
Wow.
from shifting or kicking when the weight's in there. That's just to hold it in place so your plumb was set up?
That's correct. We
Gotcha.
don't want them to move, and they don't want to move. Right? They don't want to shift around on the footing.
Right. So that gets us to the footing, and then when you attach one form panel to another one, are you using adhesive for that as well?
We can, and we do. We're trying to keep them from floating, and that's usually at the top where we see that occurring.
So it's just a bead.
By the way, what's the big question that you have about this right now? Somebody
What's
just
the big
mentioned-
question?
Yeah, I mean, I have a big question about this.
How is that foam? How is that foam and plastic going to hold the concrete? Is it?
Exactly
Yeah.
right. Isn't that
Yeah.
the big mystery? How does that work?
Yeah.
I mean, because that's so much pressure, unbelievable amount of pressure. Syed, you would know that.
Right down here.
Right down there.
I
Bead
do
right on
believe
either
that
side, and
they
then
do have those boards, like you see those boards around there right
Yeah.
now.
Yeah.
Those
snap
boards are
them
kind of
Yeah, and if you look
keeping a
underneath,
section
it's
together.
actually a male and
Yeah.
a female joint. So when you push these panels
Oh, this is
together,
interesting.
they
So this is
lock
what keeps it
together.
sealed.
You want to make sure you line up these plastic ties right here. All right. So now,
Look at
Legos.
that, even without the
It's
adhesive,
Legos.
it's all
I've
one shitty
seen that
box.
before, man.
but if you
There
look
you go.
right here
There
in
you
the
go.
form, you see these X's. If I scrape that away, dig down in, you can actually
Oh,
see
yeah.
that plastic
Oh,
tie
that's
right
what,
there.
okay.
Yeah.
If you want to screw sheeting on the outside of the wall to put plywood to it, you screw right into that plastic tie.
Nice.
So there's no wood out there.
Well, how about on the inside? If we wanted to finish off this basement, do we have to put up studs or no?
No studs needed, no wood on the walls. You can screw your drywall right into there.
Wow, that is great.
Yeah.
Okay.
Sweet.
So we build them, we start to put the adhesive down, and then we snap them together, and we go all the way up, which is what you've done pretty much all the way around.
Yeah.
And you're still going.
That's right.
So it looks like they do have some sort of
So
furring. but
Kevin,
that could
remember
mean
we
keep it-
broke this foundation.
But will you
away
make your
here,
house
all
out
this
of it?
Stone right in here. It was a lot of a loose spot.
That's the
So I
big
had
question.
Mark
Like, will
McCullough,
you
our
make your
mason,
house
come in
out of that?
Oh, I
tighten
see.
a lot of
Okay,
this
yeah.
up.
Well, for
Tighten
me,
it's still irregular.
That's
so
a lot of
can't
concrete.
you
As long as the
describe
city
the
code's
wall there?
okay, you
We
can
did.
do
We
it, but
described
you have
it
to check
here,
with the
and we
city
cut it
code,
with the
building
jigsaw.
codes.
Okay.
no, I mean,
Fit
but
right
will you
there,
trust
and you
to
got a little
make
piece
it from
just
that
for the
material for
scat.
like your house?
Yeah, I think they put
Yeah,
rebar
because
in. It's the same
You
thing.
you actually have
just keep
you actually have
scribing
a
them all the way up till
sturdy
we get to the
wall
top.
and insulation at the same time.
Come on, Alex, let's dance.
Wait, so when it save you money, right?
You know,
Yeah.
it's gonna save you time. I don't know about money.
I figure that. But I see some they do that up in like in the middle of nowhere when they find like a piece of property up in the mountains or something like that, and they build it there. But they use like
You
that
got-
type of material.
Now, I
You
noticed
gotta
the
truck
steel's
those. You
going
gotta
in.
truck those
Where is that going? How
concrete
much are
trucks
you
in there,
using?
and that's gonna cost
Well,
you. I
we're
guarantee.
using one every course.
But, like,
Look at this. This is cool. So
this.
it's
Offset
some
big.
kind of
all the way
homesteading
up
show,
to the
building your
floor,
Yeah,
house.
they're
so that
adding
when we
rebar.
drop the
Isn't that
vertical
have
down,
to.
amazing?
it'll
So every
hold the
level,
Concrete has to have
every
rebar.
level you can add rebar.
Wow,
Isn't that
every
amazing?
row and vertical.
Yeah, that makes
sealed.
sense for rebar.
Usually you'll see two pieces of
Yeah,
steel
'cause
across
I-
the
like,
bottom and maybe
plastic is
two
not gonna
across the
hold it.
top. That's all.
Yeah.
Not at all.
Are they
There's a
gonna
lot of
pour
steel, so it adds a lot of
concrete
strength.
inside of it?
Yeah.
Now, where is all
Yeah,
the?
they're gonna fill it with concrete all the way down in. Watch them do it. You're gonna see it here.
Now, another question: where is the plumbing is gonna go and like electricity?
What are you working
They
on
would,
there?
they would
Tommy?
have to do that now
Well,
as
we
well.
want to have
you know what I mean?
access to
Yeah.
electricity outside.
Wait.
So rather than drill the concrete, we're going to put a couple of sleeves in so we can run the wire through.
So they're bringing the electricity in right now, but just in one place.
Yeah, no, but I mean like for the inside, you know, like we
Yeah. Like how do you wire inside the
Yeah.
walls as you typically would? Yeah.
because like
if you
with
were
the
to build a
stuff.
house, how much you think that'll actually save you to do it that way? Thousands? Maybe 5,000-6,000?
This is amazing, actually.
Maybe spend a couple thousand on just plastic, maybe, you know?
Tommy, what do you know about the mix?
So what they're pumping in there is a 3,000 pound mix, 3,000 PSIs, with a 3/4 inch stone coming through a 4-inch hole.
And then in terms of this pour, Ken, how does it differ from a traditional form?
Well, we're going to place it in 4-foot lifts with the pump truck right in place instead of letting it flow through the forms. We're consolidating it with a vibrator to take all the air voids and make it flow around all the obstructions in the forms.
And by 4-foot lifts, you mean you'll do 4 feet high around the entire perimeter and then start again and do it?
That's correct.
That gives it a little bit of time for it to settle in, then you can come back here, less chance of blowout.
That's right. It's going to give the concrete time to set up a little bit.
So you could only hold like 4 feet, right, of concrete.
All right, so now that the foundation is poured, the next step will be to remove all the wood and all the debris down below. Then they'll waterproof the foundation from the grade down.
No, but here's
Above the waterproofing, they'll put a
Insulation right here.
I'm sorry. They still don't answer the question. Like,
What?
Let me see here. What is supporting all of that outward? Isn't it, when you pour concrete into that, isn't that pushing out at an incredible pressure?
I think they do
Yeah, but
bracing.
all those ties that they have in there, all those things that are holding it together, all those ties that are grabbing and
Yeah.
holding. There's a lot of them. That's a lot of ties. That's
That's
way
a lot
more
of
ties than
ties?
you. That's way more ties than you would have on.
Wow. It obviously works, but I would think they would need something, but
But they don't have. I don't see anything through the outside, right?
they have a little
only-
bracing here, but that doesn't even, you know, we're looking down on it, but
But they don't have any braces on top, on the outside, right?
The inside is braced, but the outside is not braced.
Yeah, that's what
well,
I'm
it
saying.
obviously
Well, we
works,
can't
but
get
it's
with
just
a
like it's.
vibrator to take all the air.
Oh, here, I want to show you this part of
traditional
it. Hold on.
Well, we're going to
Yeah,
place it.
that's
in
a lot of-
4-foot
that's a
lift
lot of
with the-
ties,
with
though,
the
guys, I'll
pump
tell
truck
you.
and right
You don't
That
see that
is,
many
yeah.
ties. You don't see that many ties on wood.
The
We're
plastic,
consolidating
the
it
Don't
with
inside
a
is the rebar,
vibrator to
right?
take all the air voids.
Yeah, the
and
rebar is just for
make
tensile
it flow
strength.
around
though,
all
not
the
for-
obstructions in the
That's just
corners.
to keep the concrete from
And by
cracking
4
and
foot
falling
lifts, you
apart.
mean you'll do 4
But
feet
you need
high
braces
around
on the
entire
other side
perimeter,
too, right?
And then start again and do it.
That's
Well, they
correct.
look on the left and right, they do, but it's
Gives it a little
not.
bit of
Yeah, I
time
guess
for
they
it
have
to settle
some.
in. Then you can
See,
come
because
back
I don't
there
see
and let's
anything
chance
through the
blow.
outside.
That's right.
No, I
It's
don't
gonna
either.
give the concrete
Yeah, I'm
time
telling
to
you, all those
set up a
ties,
little
man.
bit.
There's a lot of ties in
Yeah,
there.
you're probably
That's
right.
holding those forms together. That's it. But you see where he's standing, right? You said wood right there.
Yeah,
You see all those
that's
boards on
actually
the outside.
it's actually
All right, so
metal.
now that
Those
the
are like.
foundation is
So that's on
poured,
the outside
the
and
next
inside,
step
I'm
will
pretty
be
sure.
to remove all the wood and all the debris.
I want to show you one thing here. They're actually they're vibrating it
It's
too.
going to give the concrete
Yeah, you
time
have
to
to.
set up a
Yeah,
little
you
Get the
have
air
to.
out. You're getting the air out of it.
Yeah, and it makes it settle in.
Like in this wall, you have to.
You have to do it in just
All
about
right, so
every
now
form
that
that
the
you make.
foundation is poured, the next step will be to remove all the wood and all the debris down below. Then they'll waterproof the foundation from the grade down.
Oh yeah, there's
Above
some
the
right there on
waterproofing,
the
they'll
outside.
put a
Look.
primer on
Yeah,
it.
but-
And that primer
yeah.
will accept a stucco.
But that's almost
Yeah,
holding the wall up
Stucco
straight.
will match
Yeah,
what's
a
up on the
couple of it.
house.
And then in terms of R value, what are we getting out of this system?
Well, interesting. This is an R25, but think of
You guys know what R value is? We talked about that before.
Insulation.
Insulation value, and it's between
Insulation.
0 and what is it now? It goes up to like 48 or something like that.
Yeah.
Charlotte?
Yeah, 38
you-
for sure.
Okay.
build a concrete foundation, you pour it. The building code only requires that you insulate it from the grade down,
Not above it?
not above it.
That's where you need the insulation.
Exactly. So now this is insulated not only on the outside, but the inside. So it's insulated to an R25 and it's airtight.
And all the way up. Perfect. And then Kent, how long until we can backfill this?
We'd like to see you wait a week.
Wait a week. All right. Well, we can do that. Looks great already, so we appreciate you and you guys' help.
You're welcome.
Okay, that's cool. By the way, I learned everything about my house and from this TV show, This Old House. It's
Yeah.
amazing. I mean, I learned carpentry from another one of their shows on PBS, New Yankee Workshop. It's such a good show. Okay. Here we go. So ICF, we just learned about ICF. ICF is insulated concrete forms, and they're made out of foam. The type of foundation installed in warmer climates is, this one's kind of tricky. But anybody know the answer to that?
Is it slab on grade?
That's one answer.
So it should be all of the above.
I think it's all of the above. Yeah, I sort of looked into it and read about it, and it seems to be slab on grade. A lot of times in places that are hot and humid, like in the south, in the southeast, they use
Block.
yeah, block.
Bricks and blocks.
Yeah, exactly right. So, yeah, and they have a raised foundation. Here we go again. A rigid foam forming system for concrete is called.
What was it again? The ICF?
Isn't it ICF?
ICF.
Yeah. Anybody know what AWWF is? I looked it up this morning, so I'm just.
America's Worldwide Fighting League.
That's exactly right. No, how'd you know that? Actually, that's what came up when I did it the first time. It's all weather wood forms.
Okay.
Yeah. Anyway,
Windshield washer flute.
Yeah, exactly. Okay, this is a good one. Number 7, a footing must be on soil that is stable throughout the year, at or above the frost line, able to support the building.
E.
I will go with C.
So it turns out that all of these are true.
All of the above.
Oh, wow.
Yeah. So, but again, this is in the reading. And if I'm wrong, I've been on the phone with the publisher of this book, the company, for like a week trying to get the answers to all these quizzes in this book, and she still doesn't have them for me. But because usually teachers, they give you the answers and you can go, oh, it's this. Now, so I had to spend like 2 hours this morning finding all these answers. But yeah, so it's got to be stable throughout the year. It's got to be at or below the frost line. Like that means where the earth freezes to. So in a mile, like for example, Texas, I don't know, you guys, I know Cheryl, you're from Texas, but Texas may freeze, but I don't think it freezes that deep. It doesn't get that cold.
No, this is a fluke year right here for sure.
Yeah. So if you look in the book, this is something we don't worry about out here, but there's a whole chart in the book that you have, that the carpentry book, that's about different zones in the United States and how deep is the frost line, how deep is it expected to go. That determines a lot of different things. And able to support the building is obviously true. The ingredients for making concrete. This is so fascinating to me. I believe this. Anybody know? Water, Portland cement, and aggregates, lime, mortar, and stones.
B.
A.
A.
A. Definitely A.
Wait, what?
And how is A?
Wait.
How
No,
is?
wait.
Go ahead.
Wait, one number 9, right? Which says concrete from construction is usually responsibility of like holding together, right? Being strong, or
No, this is who does it. What? So let's look at number 8 just for a second. The ingredients for making concrete are water, Portland cement, and aggregates, lime, mortar, and stones, mortar, water, and aggregates. Okay, and the answer is A.
A.
Yeah.
Yeah.
Yeah. And
lime is already in there, so
exactly right. Yeah.
And stone is part of the aggregate.
Exactly right. And by the
there's
way,
another way.
so is sand. I was reading today.
Yeah, sand and stone.
Yeah.
There's another way.
What's that?
The Germans taught the Japanese how to do it. It's basically with like the stuff that's in seashells, a whole bunch of seashell stuff. It's that with sand and something else mixed. I think it's lye. I'm not sure, but it's like
it's lime.
It's like sand. It's like sand and stuff that got mixed together to really get extremely strong, compact, to hide like extremely strong. I'm talking about strong, like, oh my god, it's like stronger than now. I can't explain, but it's like extremely explosive that can't even get through it, man.
Because when you said seashells or something before they had lime, they in like
calcium.
Yeah, calcium. They used to use it in
like grinding down the seashells
as a mortar. They did in the United States. They did on the eastern seaboard in those 16th and 17th, and 18th century houses.
Yeah, but the Germans and the Japanese built those bunkers on D-Day.
Oh, really?
That's what I'm saying. That's a lot of damn sand.
Number 9, I do not know the answer to. Concrete form construction is usually the responsibility of
B.
Laborers, masons, carpenters, or ready. I know it's not D.
It's B. Masons.
Masons.
Yeah.
Okay.
Or masonry or something like that, right?
Yeah, I don't. This is talking about the wood to build the forms, and I don't know what. I personally don't know what union.
The masonaries makes it too. The ones that are gonna do the concrete.
Okay.
So I think it's B.
I'll tell you what. Let's do this. It's in the book somewhere. I couldn't find it, so anybody who finds the answer gets the extra award. You get to be a co-host.
Which question are you on, Murray?
Number 9.
Okay.
You get to be a co-host for the next.
Masons.
Is it Masons?
Yeah.
Yeah. It's
yes.
B. Okay. Number 10.
No, actually, concrete form. That should be.
I thought it was
carpenters.
carpenters.
It's carpenters.
I thought it was carpenters, but then
It
I'm
is
looking at
carpenters.
another union. They say it's laborers, so I don't know.
Well, isn't it the one that's gonna pour the concrete, like the forms?
Yeah,
Like,
you know
like
what?
isn't it the masonaries too?
We can
Masons do it as well, and I'm sure laborers do it. In fact, all three of those probably do it. To be honest with you, laborers, masons, and carpenters probably do it. Carpenters generally do it definitely on building roads and highways and bridges.
Okay, anybody, we can speculate all day, but Roberto,
Hello?
your job is to find it in the reading. Okay, I'm going to give you the job.